Welcome to Chapter 2, Section 2, Comparing and Ordering Rational Numbers. In this chapter, we will learn to compare and order positive and negative rational numbers. These can be written as fractions, decimals, and integers. We have one vocabulary word, the LCD, least common denominator. Let's take a look at that. In order to compare or order rational numbers, first we need to write them in the same form. So either make them all fractions or make them all decimals. To compare fractions, find a common denominator. This could be the least common denominator. The least common denominator is the least common multiple of all the denominators. Something to remember, the least common multiple of two numbers is the smallest number other than 0 that is a multiple of both. So for example, if you have the numbers 16 and 8. The multiples of 8 are 8, 16, 24, 32, etc. The multiples of 16 are 16, that's 16 times 1, 32, 16 times 2, 48, that's 16 times 3, and so on. The least common multiple of both of these would be the number 16. These are multiples. Last unit we dealt with factors. Now we're going to deal with multiples. Let's look at example 1a. We are going to compare 5/6 and 7/10. One method, and again, this is method 1, is to find a common denominator. Let's try this method. So we're going to look at 6 and 10. 6 times 10 over 10 gives us a common denominator of 60. And 10 times 6 over 6 gives a common denominator of 60. Now we can multiply by 10 over 10 because 10 over 10 is the number 1. Likewise, we can multiply by 6 over 6 because 6 over 6 is 1. So we're really just multiplying these fractions by 1 to make them look slightly different. And we can do that because we know that 6 times 10 is 60. So this goes in your notebook. So going across, 5 times 10 is 5 times 10, which is 50. And if we reduce this, it would come back to here. 7 times 6 is 7 times 6 is 42. Again, if we reduce 42 60ths, it would come back to 7/10. So our two new fractions are 50 60ths and 42 60ths. Now, if you have 50 out of 60 shaded or 42 out of 60 shaded, obviously the 50 out of 42 is larger. So 5/6 is going to be larger. By giving them common denominators, we can now compare the fractions, so we can tell what the original fractions would be in comparison. In this method, we're going to find the least common denominator. Now in the previous method, we just found a common denominator, and the easiest way to do that was to multiply the two denominators. In this method, our goal is to find the least common denominator. So we take the 3 and we list all the multiples of 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, etc. And list all the multiples of 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. And you'll see that 15 is your lowest common multiple. That's 15. Goes in your notebook. So to have 3 become 15, we're going to multiply it by 5. We're going to multiply the numerator by the same 1 so that we're actually multiplying by the number 1 because 5/5 equals 1. 3 times 5 is 15. 2 times 5. 2 times 5 is 10. To make 5 into 15, we're going to multiply it by 3. We'll multiply the numerator by the same thing because we're going to be multiplying by the number 1. 3/3 is equal to 1. 4 times 3 is 12. And as you can already see, 5 times 3 is 15. Now we have the same denominator, so it's easier to compare these two numbers. Which one is larger, 10 out of 15 or 12 15ths? Correct, 12 15ths. So when we reduce these and go back to our original numbers, we see that 2/3 is smaller than 4/5. So 2/3 is smaller than 4/5. Let's look at example 2. Sometimes we have mixed numbers. And they can be done the same way we just talked about. We can use a common denominator. But sometimes, especially if you're good at division, it is just as easy to divide these out and see what they could be. So to do that, we're going to write these fractions as decimals. This is 5 wholes and 2 nines. So we're going to take 9 goes into 2. Well, 9 doesn't go into 2, but 9 does go, if we add a decimal and a 0, goes into 20, goes into 22 times, 18. Again, we're going to bring another 0 down, and we have a 20. So we have a repeating 2 here. So this is where we get the 5 and repeating 2. 2/7 is equal to 5, and whatever the decimal for 7 goes into 2 is. 7 doesn't go into 2, so I add a decimal, and I add the 0. 7 does go into 20 2 times. 7 times 2 is 14. Subtract, add a 0. 7 goes into 60 8 times. 7 times 8 is 56. Subtract, and you can see this one goes on a little longer. 7 goes into 40 5 times. 5 times 7 is 35. And we can keep going. This is actually what it equals here. So what we have found by doing this is that 5 and 2 nines becomes 5.2 with repeating 2, and 5 and 2 sevenths can become 5.2857 ... as it continues. And so far we do see no repeating or terminate. So we have now written our fractions as decimals. Once we write them as decimals, we can see which one's bigger. If we go to 2 decimal places, this is 5.22. This is 5.28. Well, is $5.22 larger, or is $5.28 larger? Of course. So this is the way it goes. We look back at the original fractions, and our answer is that 5 and 2 ninths is smaller than 5 and 2 sevenths. In this, if you remember, we did a foldable. And we talked about if the numerators are the same, we can compare them. Because we know with the denominators, ninths are smaller pieces than sevenths. And so 2 ninths are 2 of the smaller pieces versus 2 sevenths, which is 2 of the bigger pieces. Now, sometimes we have mixed numbers. Some are decimals and some are fractions. When that happens, we need to make them both the same form, either both decimals or both fractions. I like to write my fractions as decimals. So I would say 5 goes into 2. Okay, it does not. Add a decimal, add a 0. 5 goes into 20 4 times. Oh, look at it. Remainder is 0. So this is a terminating decimal of 0.4. So negative 2/5 is equal to negative 0.4, or 4/10. Well, owing 44 cents and owing 40 cents, owing 40 cents you're richer, so that's bigger. So we go back to the original, and we can see that negative 0.44 is going to be bigger than negative 2/5 because negative 2/5 is equal to negative 0.4, or negative 0.40. So our answer goes this way, and we can thus compare the decimals. There's a third way of doing this. So far we have ordered fractions and decimals by writing them in the same form. So method 1, we wrote as fractions. Method 2, we can write them as decimals. Well, the third method is to place them on a number line. So method 3 is placed on a number line. Let's try that one right now. We have the numbers 14/4, -3/4, 6, and -2/5. Represent the percentage of change in the populations of 4 different states. List these numbers from least to greatest. Okay, we're going to place them on the number line. So that's our first step, place the number line. Let's look at 14/4. 4 goes into 14/4. 4 goes into 14 3 times, that's 12. Subtract, bring down the 0. 4 goes into 25 times, so 3.5. That's a positive number, so I'm going to go 3.5, put a dot right here, and I'm going to write that as 14/4, right there. And I did that by changing that fraction into a decimal, although when I put it on the number line, I wrote it back correctly. -3 4/10. Well, negative, I'm going to go this direction. This direction's negative. I'm going to go 1, 2, 3. Not quite half here. I'm going to say right here. It's going to be a -3 4/10. Now we have a +6. Well, that one's probably fairly easy. This side's positive, and here's our 6. And we have a -2 5/10. So -1, -2, -2 5/10. Now we can put them in order from least to greatest. -3/4, I'm sorry, -3 4/10, -2 5/10, 14/4, and 6. Well, that's it for today. You have 3 try this. I'd like you to compare on your own and try them. You can remember, you may use a common denominator. You can use a common numerator if you have your foldable and can go from there. And you can turn them into decimals. And that's it for now. I'll see you tomorrow in class.